Suppose the angle measures of triangle ABC are equal to the angle measures of triangle XYZ. Use the law of sines to show that the triangles are similar but not necessarily congruent. Let's first talk about similar. That's why I have these pictures up here. Similar means basically that two things are the same shape, but they could be different sizes. Specifically what it means, let's talk about these pentagons, or do the triangles. Corresponding angles, angles in the same position, will have the same measure. So let's say these are the same number of arcs means same measure. Say these are the same. Say these are the same. And these are the same. So the 5 angles in that first pentagon are the exact same size as 5 corresponding angles in the other pentagon. That's part of it being similar. The other part, let's say this side is A, B, C, D, E, and over here we got M, N, O, P, Q. To be similar, the corresponding sides have to be proportional. What that means is if I take two corresponding sides like A and M and write them as a fraction, that has to equal another pair of corresponding sides written as a fraction, which in turn has to equal another pair of corresponding sides written as a fraction. Guess what happens next? You'll never guess. You'll never figure it out. All right, you guessed. Never figured out this last one. This last one means that the other last pair of corresponding sides written as a fraction must be equal to the other 4 pairs of corresponding sides. Notice in each triangle, in each fraction, the 2 sides that are together are the sides that correspond in every case. Notice another relationship on the top of all my fractions. Those are all sides in the first figure. And the bottom of my fractions, those are all sides in my second figure. So all this combined, all this meaning corresponding angles are congruent and corresponding sides are proportional, that's what it means to say that two figures are similar. So how does that relate to this? Well, so suppose we have two different triangles. Triangle ABC, another triangle XYZ. Something else that's important I didn't mention before. When it tells you these two things are similar, it also tells you how they're similar. When it names the triangle ABC, it names the other one triangle XYZ. Since the A's and X's are first, it means those angles are the same. Since B is next and Y is next, it means those angles are the same. And then since C and Z are last, it means those angles are the same. It's not a coincidence. The order that you're told these things matters. Let me just write out formally what that means. It says, suppose the angle measures are equal. So the measure of angle A then is equal to the measure of angle X. Fact. Measure of angle B is equal to Y. Measure of angle C is equal to measure of angle Z. Those are facts from the first sentence. When it says, suppose the angle measures are equal. Use the law of sines to show that these triangles are similar but not necessarily congruent. To show that they're similar, we need to end up with the following. I'm labeling opposite sides with the same letters but lowercase. To show they're similar, we need to end up with the following. That A over X is the same as B over Y, which is the same as C over Z. If we can accomplish this, then we've done what the problem's asked us to do. Trying to accomplish what's in orange. So how can we do this? Well, let's see. Using law of sines, let's say that sine of angle A over its opposite side equals sine of angle B over its opposite side. Certainly true. In that first triangle, it must be true because of the law of sines. Somehow we need to get our A's and B's together. Well, let's do that. Let's multiply both sides by B and let's divide both sides by A. Let me show you how this is helpful here in a moment. It is very helpful. I'm going to take and do a similar thing with this other triangle. With the similar parts, since I use sine of A and A is supposed to correspond to x. So I'm going to use sine of x over x equals sine of B corresponds to y, sine of y over y. Going to do the same thing we did here in purple. We're going to multiply both sides by y. Then I'm going to divide both sides by sine of x. Here's why this matters. If you look what we wrote up here at the top, we said that A and x are the same. We said that B and y are the same. That means I can go right here where it says sine of y, and I can replace that with sine of b. If y and b are the same, then sine of y and sine of b have to be the same. Likewise, I can replace the x with sine of a. By doing that, I'm then saying that b over a is equal to y over x, since sine of b and sine of a are the same. I'm going to come back to that. I'm going to use that. Almost finished with this problem-ish. We've got to do a similar thing now with, let's say, sine of b over b equals sine of c over c. We multiply both sides by c and divide both sides by sine of b. If we do the same thing with the other triangle, if we take sine of y, that corresponds to b, over y, set it equal to sine of z, because z corresponds to c. Multiply both sides by z, just trying to get our signs together and our lowercase letters together. And divide both sides by sine of y. We get this. Now, how does that help us? It helps us the same way we were helped before. If you look up here towards the top again, angle C and angle Z are the same, so I can go in here and replace that Z with a C. Also, angle B and Y are the same, I can replace this Y with an angle B. If I do that, and that gives me Z over Y equals sine of C over sine of Y, which then in turn means that this is equal to this. Let me try to clear some space here to show how that's helpful. I may have to do this one more time. Let's see what happens. If we take b over a equals y over x. And we're trying to get it to look like this over here. If we multiply both sides by ax, we get bx equals ay. I'm going to get our a's and b's. Well, no, I want it to get like this. I want a over x. So if I divide both sides by x, I get a over x. If I divide both sides by y, I get b over y. So by taking this here, I've got this part, this beginning part of this similarity. I almost got it. If I take this other part here, and I'm just erasing this because I don't have space. You should not be erasing your work. Get a new piece of paper. Go cut down a tree. Something. If I take c over b and set it equal to z over y, which we've just shown they're equal, and do a similar thing. We want z and c together, and we want b and y together. If we multiply both sides by our denominators, by, which some people call that cross-multiplying, I don't. I'm a rebel that way. We want to keep c on the top. I'm going to divide both sides by z. I'm going to divide both sides by y. So we get this. Divided both sides by y and by z. Now we can see here that since by is the same as by, this is the transitive property, then that makes all three of these things equal to each other. If by is equal to a over x and by is equal to c over z, then that means that a over x is equal to c over z. So in conclusion, we can say that ax equals b over y equals c over z. And by definition, since the corresponding angles are congruent and corresponding sides are proportional, it means these two triangles must be similar. That's the definition of similarity.